Okie dokie. So this is just a quick review. This is not like how I teach systems of equations if you've never seen them before, but this is a review in case you're needing a little review or in case you have an assessment coming up and you haven't seen these for a while. So we're going to look at application problems for systems of equations. So that means usually word problems. Okay, there are 2 pages to every problem that you're going to see. Let's look at the first one. So it says drag the circle to choose the equations that would model the problem. So remember, a system of equations is 2 or more equations, in our case 2, with 2 or more variables, in our case 2. Okay, so for this problem, you're going to need to write 2 equations, and then you're going to use a strategy to solve that. So let's take one thing at a time, and I'm going to start by just reading this. You are running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you've made $78.50 and you've sold a total of 87 items. For your nightly report, you need to know how many hot dogs and how many sodas were sold so you can restock in the morning. Let H represent the number of hot dogs sold and D represent the number of soda drinks sold. Okay, so before we look at the choices down here, I want to kind of break this problem apart and kind of give you a little tip. A lot of times, certainly not all the time, but often you'll find a system of equation problem that you can kind of think in your head that it's kind of about how much and how many. In other words, we have 2 equations, right? One of the equations is going to be about how many there were of something. So we're like, if we could count them, like we lined all the hot dogs up and said 1, 2, 3, 4, 5, right? So one is going to be about count or how many. The other equation is going to be about how much. So that would be the value. So in this case, it's about dollars. Sometimes it might be something about minutes spent or something like that. So in this case it's about money, and so our second equation is going to be about how much something costs. And in that equation we're only going to have figures that represent values that represent money. Okay, so let's look at it. Let's just kind of dive in and start looking for all the things that have to do with money. And I find $1.50 and 50 cents. Oh, I should probably include which one that is. So it costs 50 cents. There we go. So I'm going to highlight that in red. And so if I highlight all the figures here that talk about money in one color, then I've got my equation pretty much, right? Because every equation needs 3 terms at this level that we're working. And so I've got them. Something about $1.50, something about 50 cents, and something about 78.50. So I've taken all the money figures and I've highlighted them in one color because they're all going to be one equation. Okay. The other number that they've given us to work with is 87 items. So that's going to be about how many. Like I said, if you line them all up and counted them, 1, 2, 3, 4, 5, 6, 7, all together, you'd have 87 things that you sold. Okay. So I'm going to highlight that in a different color. Now, I don't see any other numbers. So remember, I need 3 things to make an equation. So 87, what do you think is going to go with the 87? Give it some thought. I'm going to give you a hint. What kind of items did you sell? In other words, what things added together equal 87? Okay. Well, it says right in the beginning that I am selling hot dogs and sodas. So together, the number of hot dogs and the number of sodas equals 87. There are my equations. Pretty cool. The other thing that I want you to be aware of at this point is, what are we looking for? We got to keep that in mind, especially when we're dealing with like how much and how many. Are we looking for how much something was, or are we looking for how many There was. So let's look at the question part. It says, I need to know how many hot dogs and how many sodas were sold. So my answer is going to be the number of something, right? There's not going to be any mention of dollars in my answer. It's just going to be the number of something sold. Okay? In fact, you can see here it says let H represent the number of hot dogs sold. And let D represent the number of soda drinks sold. Okay. So I think we've broken this problem down nicely in a way that we can really understand what we're looking for, what's the information we have, and even which figures go with which figures. Okay. So let's look at our choices now. Let's see, $1.50 times H, the number of hot dogs. Yeah, that would work, right? Because every time I sell a hot dog, I get $1.50. So if I multiply the price by the number I sold, that will give me what I'm looking for. Okay, so that looks good. Plus 50 cents times the number of drinks. Yeah, that looks good. Equals 87. Whoops. What's wrong with this? Ask yourself what's wrong with this one. I hope you realize that we're mixing how much and how many, and we don't do that. So if 87 is highlighted blue, and that's going to be in the how many equation, it has no business hanging out with the how much terms, right? The money terms. So this is just out. This is wrong. And then it says the number of hot dogs plus the number of drinks equals $2. What? This is all mixed up. Okay, let's look at the next one. It says the number of hot dogs plus the number of drinks equals 87. That looks good to me. And then it says $1.50 plus 50 cents equals $78.50. Ask yourself what's wrong with that one. What do you think? I noticed a couple of things. The thing I noticed that's good is that we've got all the money together, right? And those are all the red highlighted things. So these figures do belong in the same equation. However, I've got a problem because there's no variables, right? Both of your equations are going to need to have the H and the D variables. So that's my first problem. My second problem is $1.50 plus 50 cents is $2. So this is also wrong. So this last one must be it. Let's kind of just check and make sure. The number of hot dogs plus the number of drinks is 87. Yes, hot dogs and sodas equals 87. Good. And $1.50 times the number of hot dogs, yeah, plus 50 cents times the number of drinks, yeah, equals 78.50. Yep, those are all my red figures, right? Those are all going to go in the same equation. So this describes how many, and this describes how much. So let's go ahead and draw the circle over there. Just drag it over there. And then I'll see if I can stretch it out a little bit like that. So that's going to be the first page of these little assessments that you're doing. If you're watching this to do assessments, okay? So those are our equations. So that's pretty cool. We've already got our equations done. I'm going to look at the second page, and it basically wants you just to write the equations. Just enter the equations in these boxes. So H plus D equals 87. $1.50 times hot dogs plus 50 cents times drinks equals $78.50. Okay. When we're all done solving, we'll come back here and we'll say the number of hot dogs and the number of sodas. All right, let's go ahead and solve it. There we go. So those of you who have worked with me before know that I'm really a big stickler on this problem solving process that starts with you drawing something. Right? I really think that we need to represent math problems visually, and it just super duper helps us understand the problem, and it really helps with equations and all kinds of stuff. However, these two things lead us to the equations, and we already have our equations. So I'm going to, as much as it pains me, I'm going to cross these out. You don't have to do these this time. Okay? Because we already know that H represents the number of hot dogs, and D represents the number of soda drinks. It already gave us that. Okay, so here are our two equations. H plus D equals 87, and $1.50 times hot dogs plus 50 cents times drinks equals $78.50. Okay, so if you remember when you learned how to solve systems of equations, there were several methods, right? We could kind of add them together and cancel them out. We could do all kinds of things. But I'm going to use the substitution method, and I'll tell you why. Because when I see an equation that just has a variable kind of by itself, no coefficient, I even have two of them, right? I have a variable here with no coefficient. To me, that's just kind of begging to turn into a substitution problem. So I am going to change this. I'm going to get one of the variables by itself. I think I'm going to have the D by itself. And so I need to get rid of that H. And how do we do that in algebra? Well, we subtract it from both sides. So I'm just going to subtract H from both sides of the equation. And here's what I'm going to have left. I'm going to have D. Whoops, why am I using that? Equals 87 minus H. D equals 87 minus H. Now, what this is saying is that D is the same as 87 minus H. So anywhere we see a D, we can just insert 87 minus H, right? I'll just kind of put parentheses around that because D is the same as 87 minus H. So here we go. 150 H plus 0.50. Now that says D, but up here I know that D is the same as 87 minus H. So that's what I'm going to put in there. 87 minus H equals 78.50. So I just want to point out to you at this point, the reason that we've done that and used this substitution is because now this equation only has one variable. It just has H's, and we know how to solve those. So let's go ahead and do it. The first thing I notice and the first thing I look for when I'm solving a longer equation is there any distributive property? Because that's the first step. And there sure is. This 50 cents needs to be distributed between those. Okay? So I'm going to say $1.50 H plus, we need to find out what 50 cents times 87 is. So basically that's going to be half of 87. And that's going to give me 43.5. Okay. And then I'm going to distribute the second one. So I have minus 0.50 H equals 78.50. Okay, so I've simplified it a bit. And now the next step, after I do distributive property, I wonder if you remember what's next. What's next is we're going to combine like terms. So I have an H here and I have an H here. So I'm going to combine those. And I'm going to end up with $1.50 minus 50 is going to be 1 H. I don't really need the 1 there, but I'll leave it for now. Plus 43.50, you can put 0.5 or you can add the 0 if you want to, equals 78.50. So let's go over the steps that we've done so far. So the first thing is we decided to use substitution. So we converted this so that the D is isolated, the D is by itself, and we know that this is the same as D. So we plugged it in, right? We plugged it in right here in place of D, and then we used distributive property to simplify it. So we multiplied the 0.5 times these. We got this. Then we combined like terms, and we got this. So that's how we got here. And now all I need to do to get that H by itself is minus 43.50 from both sides. This is going to cancel. I have 1h, which is just h. And then on this side, what do I have? 50 minus 50 is nothing. And 78 minus 43 is 35. Yay, so I know how many hot dogs were sold. Okay, how are we going to find how many drinks were sold? I bet you know. We're going to plug that right back into the easiest equation we can find, which is h plus d equals 87. But I know that h is 35, so I'm going to plug that in. Get the d by itself by subtracting 35 on both sides. D equals, what does that look like? 52. So I've sold 52 drinks and 35 hot dogs. And I'm done. Okay, let's go back and make sure that we enter. So which one was 53 and which? H is 35 and D, we sold 52 drinks. So we sold 52, whoops, that's a text box, 52. And then we also sold 35 hot dogs, and we're good. So that, my friends, is how, in this application anyway, we're going to solve systems of equations. Hope that that is helpful. Maybe watch it again. Sometimes the first time we hear things, our brain is busy organizing the information. And then once it's organized, if we watch it again, then it's much easier to understand because everything kind of falls into place. Okay? So I wish you luck. I know you got this, and I hope that was helpful.